Hello and welcome. Today we're going to talk about using data. So, a population consists of all members of a group of interest about which data will be collected. Since it may be impractical to examine every member of a population, a subset of the group called a sample is sometimes selected to represent the population. The sample can be analyzed to draw conclusions about the entire population. Sample data are often used to estimate characteristics of a population. Therefore, a sample should be selected that as closely represents the entire population. Also, the larger the sample size or the more samples taken, the better the represents the population. A bias is an error that results in the misrepresentation of a population. A sample favors one conclusion over another. The sample is biased and the data is invalid. The best example I've been told about this is you're making a pill that's supposed to help make people smarter. So what you do is you give it to all Harvard graduates, and then you say, "Look at this pill. Harvard graduates are all on it, and look how well they're doing." But it's not a causation. You're just saying, "I had all them take this, and they're all Harvard graduates, so there's a bias there." All right, polls. Before the 2010 elections for members of the U.S. House of Representatives, pollsters called American households on their landline phones to see how they plan to vote. What kind of sample bias might affect the poll? Identify the intended population. Well, this is all of America, so Americans. Identify the sample method. The data for this poll were collected over landline phones, so the sample consists of likely voters who have a landline. Determine potential bias. Because not all likely voters have landline phones, the result could be bias. Because not all likely voters are available for this sample. And talk about it. Some polls use both landlines and cell phones. How might this alleviate the issue of bias with the landline only sampling method? Well, almost everyone has a cell phone. Moving on. Social media. Shia wants to determine the age of average internet user. Oh, Shy? I don't know how to pronounce that name. He posts a poll with his friends on social media site asking their age. Is this a good sample? Absolutely not. If not, what kind of sample bias might be affected? It's not a good sample. Absolutely not. He asked only people on the internet. He asked only about users' age. He asked only his friends on a specific website. Yep. He posts a poll to his friends on a social media site. D. That's why it's bad. Survey organization wants to see what percent of New York citizens support a ban on soft drinks. The question posed is, do you support a ban on soft drinks which contribute to heart disease and tooth decay? All right, so this last line is adding some bias here, because if you're saying you don't support the ban, then you're kind of saying that you're supporting more heart disease and tooth decay. Identify the purpose of the question. To find the number of New York citizens who support a ban on soft drinks. Identify the potential bias. The question lists some of the health risks of soft drinks. This might make respondents bias. B. Identify interest. The bias in this question might make respondents more likely to support the ban. The bias could serve the interests of health groups who want to ban soft drinks or companies who sell competing drinks like juices. So again, By putting that language in there, you are now almost as asking the question, you're taking a stance against it instead of just neutrally asking a question. Rewrite the question to try to remove the bias. All right, if we wanted to rewrite this question, let's do think about it over here. So instead of rewriting this whole question, I'm just going to highlight the part that I would say. Do you support a ban on soft drinks? And that's it. That is the entire question I would ask. Do you support a ban on soft drinks? I would not include the contributions to disease and tooth decay. Just do you support a ban? Yes or no? Assumptions. Ooh, that's a good word. We don't like to make assumptions in math. It's absolute last resort to make an assumption. When you identify and try to remove bias, you make assumptions about what information is important for the question and what might create undue bias. For example, you need to consider whether details of the plan are relevant and whether the question includes pervasive language. Great example of language like that all throughout our government today. Check. Film. One of our friends wants to determine whether people in your class prefer to watch movies or television. She asked, do you prefer to watch movies or television? All right, fair question. Does this question potentially bias the result? Not really, it's just asking movies or television. And the reason why we're going to say it, what do they want to determine? Whether people in your class. So, friends provided only two options. That's fine. They had to pick one. The framing of the question, no, it doesn't. There's nothing that puts bias over to television over the other. So no, this is a good question. Whose interest might be served by asking the question in this way? Well, yours. You might be throwing a party and you want to know, do they want to watch movies or have television on? So this question is serving you alone. Using statistic representation. A statistic is a measure that describes a characteristic of a sample. Like data, statistics and representations of data are non-neutral. When the average of a set of data is discussed, it uses a measure of center, mean, median, or mode. However, depending on the data set and what information is being conveyed, one measure of center might not give the whole picture of the data. Even if the data is being discussed in whole, it can also be misrepresented. For example, a person might manipulate the scales of the axis of a graph or how the data are represented graphically to misrepresent the data. True, graphical misrepresentations happen all the time. There's hundreds of examples of how that happens all over the media, especially on the news. They mess up graphics all the time. Example 3, data summaries. Teaching. A teacher wants to tell his students how the average student did on an exam. So he looks at the scores in his gradebook. 2 students score a 0 because they stopped showing up for class in the last month and did not take the exam. He uses the mean 71 as the measure of center. Does the mean accurately represent these data? Not really. By including these 2 zeros, it's absolutely tanking these results. If we take a look right here, if we get rid of those 2 pieces of data, we have everything is 90 or it's not 90, everything's 80 or above. I'd say probably looking at this, probably upper 80s is the average. This is saying 71. That means that most of the people in the class are just barely getting a C, which is not the case. Identify other measures of center. Round your answer to the nearest unit. All right, let's grab a handy dandy calculator. Oh, they just want median and mode? Sure, I'll justify that. All right, now the median of our data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means 5 on each side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 87 is the median. And the mode is 91. Analyze the measure of central tendency and how they align with the information the teacher wants to convey. The mean, 71, is bias, or it's not right, by the 2 zeros. However, no one who showed up for the exam scored below an 82, so the mean does not do a good job indicating the performance of students who took the exam. The median, 87, by the extreme value. Yeah, if we took out the two, it'd be, well, if we took out those two, it'd be 88, which is still about center. The median, blank. I'm not sure what I'm supposed to, the median here isn't biased. It's, I don't know, it's more stable, more accurate by the extreme values. Is less affected. It provides a more accurate average of how students performed on the test because it includes the scores of the 2 students who did not take the exam at all. The mode 91 is both the score most students received and the highest score received on the exam, but it doesn't accurately portray how students performed on average. All right, next up on data manipulation. Let's see. Because the teacher wants to discuss performance of students who took the exam, the mean is not the best measure of center. It indicates that all students who took the exam performed worse than their actual score. So we wouldn't use the mean here. And let's just do that real quick. Let's take away those 2 data points. 82 plus 83 plus 85 plus 87 plus 88 plus 88 plus 91 plus 91 plus 91. That gives us 786. And divide that by 9, 87.3. And the median's 87. So yeah, that's a pretty good one. All right, last page of these notes. Karen writes down the numbers of books she has read for each of her classes so far. 5, 6, 4, 5, 5, 6, 5, 4, 5. Using the mean, 5, she says that she reads about 5 books on average for English course. Does the mean accurately represent the data for this situation? I would say yes. Our entire data range is from 4 to 6. So it's not being overly influenced. It's not being overly influenced. Doesn't matter how many pages, they're only talking about books. So yeah, this is a good one. Data representation. A group compares 2 soccer players who play the same position for different teams. They make a graph of the number of goals scored through the season for each player. Do the graphs misrepresent the data? Whose interests might be served by this representation? Well, okay, well, let's see. Oh, take a look. We have something different here. So our x-axis are the same, but the y-axis are different. This one counts by 5s, this one counts by 10s. They both go to 30, but this one looks lower. The y-axis are using 2 different scales. So players 1 might get some favorable bias out of this because for some reason we're counting by 10s here instead of 5, so this one looks a lot less. And if you just throw these 2 graphs up and eyeball it, unless you notice that, player 2 looks worse. Identify the purpose of the graphs. Purpose of graphs is to compare the number of goals. Identify the difference in the graph. We've done that. The second player goes up by increments of 10. The other one is increments of 5. Identify how this affects the representation of the data. Although the numbers are the same, the scale of player 1 makes it look like he is scoring more goals than player 2. Yeah, we just talked about that. And finally, identifying interest. The misleading representation of data makes it appear that player 1 scores more goals than player 2. This bias could serve the interest of the team sponsor of player 1's team or player 1's agent. Correct. This makes player 1 look way better than player 2, though they both scored 30 goals. If the two graphs had the same scale, then think about it, but we're comparing a goalkeeper and a forward, how might the data be misleading when comparing the skills of the two players? Typically, a goalkeeper doesn't score. So even if it was all the same, we're comparing apples to oranges here, not apples to apples. Use a source, find a graph or set of statistics online, ask yourself, are the data accurately represented? Whose interests are served by the graph or statistic? That's a good use of your time to find some of that. And that is the end of our notes. Thank you so much.